Hello and welcome to this session of the simulation series webinar. Uh, I can see that there are a lot of people who are connecting, so we will probably start in 1 or 2 minutes. I will wait a little bit that people can connect. Thank you. Okay, so I think we can start. So first of all, welcome everybody. So welcome for this episode 3 of the simulation series. This is a series, a webinar series where we talk about simulation, as you can guess. So the two first episodes were on the electric e-bike and also on electromagnetism. So this third session is about, let's say, an application of the different type of simulation we can cover on industrial equipment. This industrial equipment is this B excavator model. So I think you can see it on the screen. Just can you go in the Q&A and just make sure that you confirm if you can see my screen? Yes, perfect. So there is a chat. So thank you guys. So let's start. By the way, my name is Eric Chastanet. I work as a Dassault System, as a, let's say, a simulation expert. Yeah, as a simulation expert, and I have a strong background on fluid mechanics. Okay, so let's start. So for this webinar, during this webinar, if you have any question, do not hesitate to ask question during the webinar. I will not be able to answer it directly. I just will take a few minutes at the end of the session to answer to your question. And if there are too many questions and some questions where I don't have the answer, don't worry. I will still send you an email later where I will be able to take the time to read properly all the question and to send the answer. So don't hesitate to use there is the chat, and also there is the Q&A section where you can ask your question. And by the way, before the first question is usually, is there a recording available? Yes, there will be a recording available for this session. So don't worry if you have to leave, I don't know, after 30 minutes of this session and you don't have time to follow all this session. This is not a problem. And at the end, I'll also show a link on the YouTube where you can access to all of our content, all of our webinar sessions. So if you missed the two first session, you will still have an opportunity to watch them on the YouTube channel. So I will start with a video. So this is a customer. This customer, it's a SolidWorks customer. This customer is Resemin. It's a Peruvian company. So they do industrial machine for mining, for the mining industry. And this machine drill holes in the mine. And here it's an experiment, and they are testing the drilling components. And if you watch at this time the video, here you can see that the part is falling. The part is falling because something break in the machine. And this is really this is an experiment, hopefully, because if this happen on the field for this company, they have to pay back the loss of benefits to their customer. So imagine a machine like that on a mine, in a mine, and it's broken. I mean, it can really have a huge warranty cost for Resemin. So they really have to try to anticipate this type of failure. And in this session, we'll see some of it, I mean, how they can do to try to anticipate this type of failure. So here is the agenda. So first of all, we'll talk just a little bit, it's just for the context of the tools we will be using during this session. So we'll talk a little bit about the 3D experience works, what it is exactly. You know, you probably already know SolidWorks, but what is 3D experience works? Okay. Then it's the most, let's say, interesting part. It's where you will see the most of, let's say, application. It's the big excavator MODSIM example. So here, what I took a lot of, let's say, example challenge we can face for this type of machine. And we'll see how with our tools in the system, we can handle this type of challenges. And then the third session will be the key takeaway, the things to remember, and also some other slides about the YouTube channel, etc. First of all, we have a question for you. Uh, so yeah, right now you should have a question. So I guess this is an easy question because all people who are answering the right answer. So at least maybe you already know this type of approach regarding the simulation. So I think I can stop the poll. Okay. So everybody got the right answer. The answer is yes, modelization and simulation for sure. So before starting with what we call the MODSIM approach, let's talk a little bit about the 3D Experience Works portfolio. So what is the 3D Experience Works portfolio? So in Dassault System, as you know, as you may know, we have a lot of brands. So you probably already know the SolidWorks brand, the Katia brand also, which is very famous. And we have also other brands like Geovia, Biovia, Simulia, which is the brand dedicated to the simulation products. So we have a lot of technologies, and the idea is, okay, we have a lot of technologies, but most of the time, these different technologies, they are disconnected one from each other. And it could be nice to have like something where we can connect all these technologies together in order to work, let's say, in a connected environment and yeah, in a universal environment. So it's why we develop what we call the 3D experience platform. And the 3D experience platform, it's a platform which is accessible through a web browser, like, I don't know, I will name it like Facebook, and there you can directly access to your different tools, to the different application you need to do your job. So some of the application will be, for example, from SolidWorks. Some of the other application could be, I don't know, from NetVibes, from depending if you want to manage your data, um, if you want to do some project management, some design, some validation, it depends. But we have all of these tools connected together in this environment. So the main domains we cover with our solutions are for sure the design with SolidWorks, with Katia, for example. We cover also a lot the simulation with Simulia brand. We can cover also the manufacturing and the production, the governance in terms of data management, and also we have plenty of tools, plenty of application for the marketing and sales, like the visualization of a product and etc. So here, the two domains we'll focus today are for sure design engineering with our regular SolidWorks and Simulia brands with all the technology from Simulia, or not all of them, but we'll cover let's say five big technologies from Simulia, um, and we'll see how they can connect everything together to have let's say an integrated workflow. Okay, so we have a second question for you before starting, let's say, the technical part of this webinar. So did you already use the simulation, digital simulation? So this is some company has some tools, some simulation tool, sometimes from Dassault Systèmes, sometimes from competitors. And a lot of companies, sometimes they don't have simulation tools because they don't think they should invest in simulation. But what we'll see today is simulation is not reserved to experts. Simulation is really design oriented. With SolidWorks things, we like to make things easy. So usually it's better to have a shorter development cycles. Okay, so I can see that, let's say it's approximately 50%. So 50% of you already have probably or already used simulation product, and the other half, they never used the simulation products. So thank you for this poll, for this answer. And now let's start with a real presentation. Okay, so we are going to see some example of what we call MODSIM examples, so modelization and simulation. So as you can guess, MODSIM is really the fact that we want to integrate the simulation in the design path. So to do so, we have to have a simulation or a validation tool which is oriented to the designer, because it's the designer who should try to do at least a first draw of a simulation to try to see if he's going in the right direction or not in the design. So the MODSIM is really trying to have the simulation accessible by, let's say, a designer. We pick up 5 big challenges for this big excavator. So the first challenge is, let's say, the most common challenge we can face is, I want to make sure that the design I will build is robust enough. Okay, so this is, let's say, the most common challenge we can face usually in the industry. Will my design be stronger enough to resist to this type of load or a small overload? Okay. Then we have a second challenge, which is a little bit different, which is the safer protection cage challenge. This challenge is not a performance challenge. This is, let's say, we could say a security challenge, but in more generally speaking, it's more a regulation challenge. I mean by regulation, the company who is designing this type of equipment, it will have to pass this, let's say, this test. Even if he did a lot of simulation and all simulation are good, at the end, he will have to do this type of test because this is, let's say, in the norms, okay? So this is a little bit different, is that in all of the case, they will have to do a prototype because for legislation, they have to do this test. The third challenge, it involves other type of physics, which is about the comfort in the cabin. So here in this challenge, we'll see another domain, which is the fluid, the simulation of the flow. And we'll see that we can cover this in 2 different aspects, let's say in an internal flow in a system, or let's say a bigger domain with more, let's say, more physics, which will be considered for this type of simulation. Then the fourth challenge, safe and comfortable seat. This is more a manufacturing challenge. And here we'll see that some parts, for example, are designed in plastic, and the idea when we design a plastic part, injected plastic part, is to make sure that this plastic part can be correctly injected, okay? Because this can be very expensive to design the mold. It worth more than $10,000. $10,000. So it can be very expensive. So before launching the production, we can run some simulation to make sure, okay, if the part will be injected properly. And the fifth challenge, it's a domain we don't talk enough, which is about electromagnetism. And this is just one application of electromagnetism. If you want, by the way, to know more about electromagnetism, you can go on YouTube channel and watch our previous episodes. But here it will be on antenna design. And here what we'll see is where we should place the antenna on the machine and what type of impact it could have on let's say the field, the IMAG field. So let's focus on the first challenge, which will be to enhance the durability. So first, we'll start in our regular SolidWorks. The geometry of the assembly is probably saved in local on your computer. So we'll start directly from the SolidWorks interface and we'll save just the top assembly on what we call the 3D Experience platform. And just by doing that, all the assembly and all the components will be migrated to the cloud, to the 3D Experience platform. And then directly from this SolidWorks interface, we will launch our simulation tools, which is really integrated, let's say, there is a connector integrated in SolidWorks interface. So here now you can see what is the 3D Experience platform. So this is the environment you will see during all of these webinars. So now we can see that our boom assembly was saved on the 3D Experience platform. On the left, you can see that there is a simulation tree, but we won't really focus on this. At the bottom, you have some action you can use to try to set up your simulation. So once we have saved the model on the 3D Experience platform, we want to do a simulation of this assembly. What we do is that we'll do a little bit some modification on the boom. Usually the boom is made in SolidWorks with sheet metals, And in order to speed up the simulation, we'll replace this solid sheet metals by made surface. This is very common in simulation to do that. It saves time when we want to run the simulation. So here what we do is we have some automated tool which allow to do that automatically and generate automatically a mesh. Then we'll also use this bucket for the simulation. And here we set as rigid because we don't want really to see the deformation on the bucket. We just want to mesh it because we will apply some load on it, but we will not really deform it. So this is another way to save time in the simulation. And then we also replace all the hydraulic cylinder by beam elements. So this is other type of connector. We have plenty type of connector we can use. And using this, we'll be able to model the deformation we could have in a hydraulic cylinder without really simulating all the complex, let's say, mechanism of a hydraulic cylinder. Then, as we have created mid surface for our boom assembly, this mid surface, because they are mid surface, they are probably disconnected one from each other. So what we'll do is that we'll create some welds between each mid surface. And again, here we have a tools who do that automatically. And good thing is also we can specify a type of material for this weld. So it's what we can see here. It's in yellow. It was the line fastener. So we have plenty of type of weld. We can do linear weld. We can do also a weld, punctual weld. So we have different type of welds. We will also connect this cylinder to the boom, so we can do some welds, or we have also other connectors or coupling we can use to do so. And then after, the next part is to, let's say, to run the simulation. So we already apply some loads. We already applied some loads. Good thing is if we have set up already a simulation and the geometry change and we have a new revision of a part of the assembly, we can just replace by the new revision, and then we can rerun the simulation automatically. In this case, it's what we have done. We have run already a first case, and then here we are just replace the setup with the new revision, and now we can directly compare both of the revisions. So this is a very nice tool because in the same, let's say, display, you can compare, save the previous result of the simulation and easily compare the two simulations without having to do many manipulation of the simulation. The setup is exactly the same because we just replace the old revision with a new one. So here we have seen how we can let's say, set up, let's say, a regular structural simulation, which is very common in terms of simulation on with these tools. But now what we'll do is that we will focus more on, I think you can see my pointer, we'll focus more on this part, which is a road, and we'll see now what if this we apply a repeating load, because maybe, I mean, it will not do just one or two deep. I mean, yeah, maybe we act a lot of times, and we want to see if it can last in the time. So now we'll focus on this specific road. So again, we are creating a mesh for this specific part. And here you can see that we're applying, you will see we're applying what we call a X mesh. This is advanced mesh. We can generate this type of mesh with let's say with some cubes. This type of mesh, for example, we cannot do it in SolidWorks simulation. We need let's say advanced simulation tools or simulation capabilities to do this type of mesh. And we do have this type of mesh now with all the technology we have on the 3D Expanse platform. So after doing the mesh, we are applying some loads. And here what we'll do is that we apply a lot of different loads, and we'll solve each load in what we call different step. You can see here we created different steps with different road orientations, and we will solve all of this load manually. So these are different type of load that the road can have in its life. So now what we do is that we run the simulation. By the way, we run the simulation on the cloud. Okay, we can run it in local or on the cloud. This is integrated on the cloud, on the tool. So here you see that we have we have plenty of simulation result on each load. But now what we do is that we'll create a durability analysis. It means that we will replicate a lot of time each of these loads. So here, what first thing we are doing is we are choosing a surface finish, because this is very important in the crack propagation. And here we are choosing the load we want to apply and to replicate. So we can enter a number like 1 million times, or we can also use some signal data. If, for example, you have put a sensor on your machine, and now you see that this is the type of variation of load you can get, you can directly use this signal. And with this type of feature, you can really go, in a, let's say, advanced way of anticipating the life of your project. So once again, we run the simulation on the cloud, and once the simulation is solved, here we can see the log of life, which is the logarithmic of life. This is a very common way in fatigue for the fatigue expert to estimate the life of a project. So if we conclude just this first part, for your information, the tool we have used is Durability Performance Engineer. So it's an application we do have available on the 3D Expanse platform. And with these tools, with this solution, what you can do is you can run some structural simulation with static, a little bit of dynamic. For the dynamic, we'll see in the next part. What we do have, we have maybe more advanced tool for this. This tool is based on Abacus. And Abacus is very important. Maybe you already know Abacus, maybe you don't know Abacus. So for those who don't know Abacus, Abacus is, let's say, the most famous structural simulation solution used in the industry. It's very, very known. It's very powerful. And when I say it's really Abacus solver, I can really take an Abacus file and run it directly on the cloud. It is really the Abacus solver which is behind it. The problem with Abacus we had previously is the interface is a little bit complex. And with the 3D Expanse platform, it makes the power of Abacus accessible, because we didn't see it here, but we have a assistant, a wizard on the right we can use to try to simplify the setup of the simulation. And it allows you also to have some very robust and powerful simulation. This is very important to have, let's say, this type of robustness. Also, another advantage we do have compared to our regular SolidWorks simulation tools, it's advanced mesh. We have seen, for example, for the road, what we have some hexa in the mesh, some cubes, let's say, cubes elements in the mesh. This is advanced type of mesh elements, and this we can do it thanks again to the Abacus technology. And we can also let's say, complex material behavior like fracture, damage, non-linearity, plasticity, and stuff with like for the seal with rubber materials. We can really model advanced non-linear material. Okay, now let's have a see. Let's see the second example, which is the safe protection case. This example, so as I said, this type of simulation, we need to do it not just to make sure that this is robust enough, but also because this is a normative test. And in all of the case, we will make the test in real. So in this case, the simulation is very important because you can anticipate, let's say, how it will deform before doing the test, okay? Because the test is very, very expensive. So this will allow you, for example, to reduce the number of prototypes. So what is a little bit, so you can say, okay, this is still structural simulation, right? But here, a little bit more advanced because let's say you have more dynamics. Okay, for example, when you have an impact, you have to use some crash test. You have more dynamics. So the type of solver you need behind it is a little bit more advanced. So let's have a look. So here you can see that this is still the same interface where we'll define the structural simulation. So here what we do is that we're creating what we call an explicit dynamic step. And I was talking about high-speed events and different technology. Yes, we need what we call the explicit solver to handle this type of simulation. It's also what we use when we do some crash test. We also use the explicit dynamics solver. Here we are also using another interesting capability, which is the general contact. The general contact, it's a contact which will detect, let's say, all the contact in the simulation when the geometry will deform. So we just do the general contact and automatically all the contacts are automatically detected during the simulation. We will push the top sheet metal, let's say the top plate, we'll push it 150 millimeter down. And here we can see that the geometry is really deforming a lot. You can see. So we have some advanced behavior on the front tubes. We can get, for example, the force, the reaction force to try to push down the cap. So here, what we have seen is it's another type of simulation we can perform, let's say, with more dynamics, with more deformations. And again, the solver which is behind it, it's still Abacus. It's still Abacus. It's still the same interface. I mean, it didn't change from the first interface. So what is interesting is maybe you change of tool or you change of application, but it's still the same interface. You don't have to relearn everything. The buttons are still located at the same location. I mean, the tool is very similar. What is a little bit different is that just sometimes you have one or two options more because this solution allows you to do one or two things more. So the solution we use this time is what we call structural mechanics engineer. This is exactly the same tool we have seen previously. We add just the explicit solver in addition, which allows you to do the dynamics. But this is exactly the same tools. So again, if it's the same tool, we have also all the machine capability, all the contact, all the advanced material, etc. Okay, so let's see a third example. And the third example we'll cover, the first challenge, is about the cabin, the comfort in the cabin. So when we design a cabin, so this is also available for all the automotive industry. Um, we have to do we do some, let's say, HVAC, what we call HVAC simulation, so flow simulation, to make sure that the ventilation is located at the right in the right direction, at the right location, and that the mass flow, for example, for all the outlets of the HVAC system are approximately the same. For example, we don't have too much mass flow, air flow located on the head, and nothing, for example, on the feet, or this type of stuff. Okay. So to try to anticipate this type of behavior, what we can use is some fluid simulation tools. And here it's what we are going to see. So again, we start from SolidWorks. I think this you probably all know the workflow now. So we have saved the SolidWorks assembly on the platform, and directly from the SolidWorks interface, we can launch the 3D Experience platform. So here, what is important is that we have a solid geometry. We just have let's say, the parts, we don't have the volume, what we call the air volume. So one thing which is very interesting with this solution is it will automatically extract what we call the fluid domain. You don't need that special advanced tool. This does it automatically. So we just have to indicate, okay, where is the inlet, where is the outlet. So it will close it automatically, and then it will extract the fluid domain. So here you can see on the right, we use a lot what we call the assistant. And the assistant is very interesting because it allows you to simplify and to guide you to do the setup. Me, I used the flow simulation of this solution almost every day. And even if I know very well this solution, I keep using the assistant panel, which is located on the right. Not because it's complex. I mean, it's easy to manipulate, but it's just because it makes things so easier, and so clear. For example, did I generate my mesh? Oh, yes, because mesh is already checked. Okay. Did I set up my boundary condition? Yes, I can see that I already set up my three type of boundary condition I want to set up in my simulation. It makes things really more easier to remember and to set up. So it's why I think this is very, very interesting. So by the way, we have this assistant for structural simulation, for fluid simulation, and for the other type of simulation we'll see next. So after we set up the let's say the physics, we will generate the mesh. One thing which is important in the mesh is it's during the mesh process that it will extract the fluid domain. So here we can see that we have automatically extracted the fluid domain. We use a different mesh also to model the filters. Then again, we'll be able to run the simulation on the cloud. So here we can see some streamline, so to see where the flow is going. So this is, I mean, we have all the post-processing tools we can have in the fluid simulation. We can do some cut section. We can get, for example, the reports, the mass flow on each outlet. We can see here we are looking at the pressure drop in the flow channels. So now say, okay, we have a design, and maybe we want to try to see what is the best design. Okay. And what we'll do here, we'll do a parametric design study where we will do some modification of the design, and the design is done in SolidWorks. So what we can do is we can get some design parameter directly from SolidWorks and pilot them from the 3D Experience platform. So here we just get, for example, the length on the diameter of the tube, and then we will vary these variables, and we'll see how the behavior of the flow will react. Okay. So when we do that, so we can run again the simulation on the cloud, or the simulation in plurals, because here we'll have many simulations. So here is what we are doing. This time we are running it, okay, not on the cloud, but in local, but we can do it on the cloud. And here, so we have run several simulations, several design points. So the design point was, let's say, calculated automatically in function of the variable we put, the number of variable, and the number of runs we wanted to do. So for each design point, we can see the different, result we have, the pressure, the velocity, if we have some curves. And also, we can directly select 3 or 4 design and directly compare them and put some KPIs. So for example, I want to have, let's say, a difference in the mass flow, which is less than, I don't know how many percentage, etc. And this way you can choose what is the best design. Okay, so now we have did a simulation for the, let's say, internal HVAC, for the internal conduct, for internal piping of the HVAC. So now, what if we put this really in a cabin? Okay. So here, what we are going to do is we are doing another simulation directly in the cabin, and for this we'll have more physics because we'll really consider, for example, that we can have some radiation from the sun. So we can have, yes, we do have the radiation available, and we can also consider the behavior of the human body with what we call the thermal comfort. This is a common type of simulation we can do in CFD. So really, it's okay. We declare this body as a human, and we see, for example, the head. It can feel this type of temperature. The arm, it can feel this type of KPI, etc. And this is, let's say, a very common way to model a human body in terms of thermal behavior. So again, we use the 3D Experience platform to do that. This time, the solution we used is Fluid Dynamics Engineer. So this is another application which allows to do a fluid simulation. So this type of solution is very interesting because as it's located on the platform and the platform is connected to SolidWorks, so you have really an integration between the um, the SolidWorks, I mean your CAD system, and also your simulation. So this type of solution, it allows you to see where the flow is going in your design. So you can do so internal aerodynamics. You have different physics in terms of thermal physics, a little bit of multi-phase physics. We have different turbulence models. The turbulence, by the way, this is a RANS approach. The RANS approach is the most common used approach in industrial application for the fluid simulation. It allows you to have, let's say, an accurate result of the turbulence with, let's say, a small resolution time. Okay, because in CFD, if you want to have a very, very, very accurate turbulence behavior, you need a lot of computing power. And usually what we use in the industry is the RANS turbulence because this is a good compromise. So let's have a look now at our fourth challenge, which is about the seat. And here, as I already introduced, this is more manufacturability issue. So the seat will be composed of plastic parts. And what we want to make sure is this plastic part can can they be manufactured first, and also are they after being ejected in plastic, are they strong enough? Okay. So again, we'll start. This is the back cover on one of the parts of the seat. No, this is not the back cover. I think this is for the arm, the support of the arm. So this plastic part, I mean, it's designed in SolidWorks. Then we save it on the platform. And here again, we are in the interface of the 3D Experience platform. So you can see on the right, you have the assistant panel. So usually with plastic, the first thing we do is to choose the plastic material. And we have, let's say, more than 5,000 different plastic material with very accurate data. And this is growing and growing, the number of plastic provider we are adding in this material data. Then we set up the injection location. For the injection location, we can use directly a part, or we can also automate the injection location. And then we will run the simulation. So we'll see here the flow behavior, how the flow is filling this cavity. Then we can also have the deformation due to the cooling of the part. So it's what we call the warp deformation. And if we inject some fibers in the plastic, we can see the orientation of the fiber. So this is very important to have this orientation, because after, if we want to do a structural analysis, it's what we are currently doing. Based on this fiber orientation, it will have an impact. So here we are now doing a structural simulation where we will import the fiber orientation, the fiber which is from the plastic simulation. And here we are see an impacting simulation, and we see now the von Mises in the stress in the parts and the deformation in the parts. Okay. So say, okay, maybe my part is not robust enough. So we do some modification in SolidWorks. We just update the model on the platform. So we just save and update the model. And again, we go back in our plastic, and we don't have to redo all the setup. All this, because we just change the parts. So we just have to replace it with a new revision, for example. And then we just have to rerun the simulation, and we can see again the new flow behavior. So in the flow, what is very important is also to try to avoid the well lines, locate also the air bubbles, the air trap you can have on the parts. So here we are looking again at the warp. So the part is deforming after it cools. And after we rerun the structural simulation, and we see now that the deformation are less, there are less deformation. So here, what we saw is what was very interesting is what we used two tools. And the first tool was a plastic injection engineer. So this application allows you to do the simulation, let's say, of the plastics, of the plastic filling the cavity. And we also use another tool, which was structural mechanics engineer. It's the tool we saw at first to do the structural simulation. And we can combine these two workflows. So this is a very interesting combination of simulation we can do. So for the plastic injection engineer, so this type of solution, it allows you to estimate the filling of the cavity, which is very important for this type of tools. For the plastic injection tool, is the database, because the material data, it's very complex to get it if you're a user. So only, let's say, the laboratory can provide you this type of material data. Even sometimes, even the plastic manufacturer, they don't have all the filling data to perform this simulation. So you have to pass through a laboratory to really try to estimate the different viscosity you can get in function of the temperature. And what we are working with a lot and more suppliers, plastic suppliers, in order to try to get their data from their materials, from their products, so we can get really a good accuracy in terms of material data with their materials. Then let's see the fifth example, which is about electromagnetism. So the fifth challenge is we want to place some antenna on this industrial equipment. So we'll see that, again, we start from SolidWorks, and we'll see that the interface this time is a little bit different. It's a little bit different because the tool which is used is CST, which is a very famous tool for electromagnetisms. But this tool is also connected to the 3DEXPERIENCE platform. So you can directly import automatically your design to this tool. So we locate an antenna at the end of the roof, and then we'll choose some solvers. So we have plenty of different solvers to try to model to model the radiation of the antenna. And then once the simulation is set, again, we will be able to run the simulation again on the cloud. Here, what you are seeing is the cloud, the free experience platform on the web browser. It means that these results are accessible directly on Google Chrome or Mozilla Firefox. Also, you can also visualize these results on your smartphone, for example, because this is really on a web browser. So here, what we do is we're comparing two simulations, so two different placement of the antenna. And we can see, for example, on the right that you have a better radiation of the antenna than on the left, because on the left, it's a little bit, let's say, hidden, it's in a hole. So the antenna will not, let's say, work as expected. So the best location is on the right. What we can do after, say, okay, maybe in the middle of the roof, it's a good location for the antenna, but we can add some protection because it's working in a mine, for example, so it's an aggressive environment. So then we can design, I don't know, some protection cages around it and to see if there is an impact also on the antenna. So this is really a common application we have. We do have a lot of customers who do some antenna integration of the designs, and they are very happy when they can anticipate this type of behavior, with the placement of the antenna. So the solution we are using is electromagnetism engineer. In fact, in reality, the tool behind it is CST Studio Suite. Electromagnetism engineer is CST Studio Suite, which is directly connected to the 3D Experience platform. So CST is for electromagnetism is the equivalent of Abacus, what it is for the structure. So it's really a very famous technology used in this type of industry. And which is very nice with this solution, it's that it can cover a lot of domains, a lot of applications. So here we see that it's just on antenna, but in reality can also do some what we call low frequency analysis to do, for example, for the electronics motors, everything with magnets. We can do also some signal integrity when the signal through a bus, a PCB, electronic cardboard, to see if the signal, when it go through the different, I don't know, bus, and you have a lot of bus close to each other, you can have some interferences. So you can do a lot of different application with this type of simulation. Really, if you want to know more about electromagnetism, if you face some issue with electromagnetism, you can go on our YouTube channel. I will give you the link at the end of this session to know more about the different application we can cover with this solution. Okay, so what we have seen in this example, so first we have seen that we can do some structural simulation to try to validate a consumption to make sure that, for example, the design is robust enough. So this was the first example we have seen. In the second example, we have seen that with also this type of simulation, we can cover also what we call high dynamic events with the explicit solver. So here, what we have seen is that we did a simulation to reproduce, let's say, a normative test. Then in the third challenge we faced, it was about fluid physics, and we did a simulation to simulate the flow inside the cabin. In the fourth challenges, we did a plastic injection combined with a structural simulation test to make sure that the plastic part we created is robust enough. And we could directly import the fiber orientation through the plastic filling simulation. And in the last example, we have a place where some antenna, and we have simulated the radiation and the irradiation of this antenna. And we have seen that it has, the location of the antenna just on the roof has a huge impact on the way it will behave. Okay, let's have some key takeaway, but before the key takeaway, let's have a third poll. So Okay, this is very interesting. So in terms of repartition of what I can see is most of you are interested by the structure. Usually when we cover simulation, structure is approximately 70% of the application. And it's exactly what we have here in the polls. So this is very representative to our customer, the application. And what is a little bit different is a lot of you are also interested by plastic injection and also by electromagnetisms. So this is really interesting. Usually this is fluid, which goes seconds, but here fluid is the last one. But this is very interesting. So again, for electromagnetism, we'll see that we have another session on this. And for those who are interested for structure and plastic injection, I mean, don't worry, we can contact you after the webinar to show you more of the capabilities of our solution. Okay, so let's try to see the key takeaway. So what we can remember of this presentation in terms of, let's say, engineering benefits. First, what is very important is we have this connection between the SolidWorks and our validation tools. Or maybe you're not using SolidWorks, maybe you're using CATIA. It's possible. We also have the same thing. CATIA, I mean, CATIA is also from Dassault System. We have the same connector, so we can directly connect your CAD model to this solution, to the simulation tools. And if you do a modification of the original model, you just have to update the simulation. You don't have to reset up all the simulation. Okay, so it makes really things faster to rerun some design exploration. So it's the second topic. Big thanks to this connection between the CAD tool and the simulation, we can do some design exploration very easy. Also, what is interesting, especially in the fourth example where we did the injection of the plastic on the seat, is that we can combine this different technology. See what is the impact of, for example, the fiber orientation of the plastic part, what is the impact on the structural side. And here, this is very interesting to couple of this type of physics, because usually everything has an impact on everything, So when we can really combine these different aspects, this is really a key differentiator in terms of accuracy. Also, what is very interesting is thanks to this integrated of the environment, it's easier to collaborate. Why? Because, for example, as the data will be located on the cloud, if you have an issue with your laptop, or if you have to travel from one place to another place, there is no data loss because everything is stored on the cloud. Also, you can directly visualize the result again in a web browser. So you can, if you want to show the result, I don't know, to a manager and you don't have your laptop, don't worry, you can just pick up your phone and you can show in live on the phone directly the result of the simulation, in 3D, So this is really interesting for the collaboration. And also what is very important is with all the solution I showed you, you can run the simulation in local, or you can choose on the cloud, and it's integrated. Depending on the solution, you can go up to 16 core on cloud. And if you need more, we still have some solution, what we call credits. So you can rent up to 144 core on the cloud. In terms of business, this type of, let's say, connectivity between the CAD and the simulation, it allows you, so the MODSIM, what we call the MODSIM approach, it allows you to have a faster time to market because it reduces a lot the development cycles. It allows you also to do more easily some design exploration. So if you can explore more design, you can be more innovative. The more physics you're adding, the better you will understand how your project will behave. So the less prototype you will have to pass some compliance test or for the warranty cost. Because also you'll be able to collaborate more easily because you're sharing results. For example, in a web browser, you will be able to work more efficiently. And also with all the cloud computing, you don't need a big cluster to run the simulation because you're just using the cloud. So you reduce a lot the cost of the hardware. So here, just a summary of the simulation solution we do have available on our 3D Experience Works portfolio. So just for the structure, we can see that we have a lot. If you're going from the left to the right is the one which has the most possibility, which include all of the capabilities which are on the left. So here, what we have seen is that we have used the durability performance engineer, which is this one for the two first simulation, and for the third simulation, we have used durability and mechanics engineer, which include also the explicit solver. For the fluid simulation, we have used fluid dynamics engineer. For the plastics, we have used plastic injection engineer. And for the electromagnetism, we have used electromagnetics engineer. We have another one which allows to do some comparison when the simulation is run, which is called a simulation collaborator. I want also to show you that recently we package all our training lessons in different categories. So if you are already one of our user of simulation, I don't know, Abacus user, or I don't know, CST user, and you only had access to one training session and you want to see what can do the tool in its globality and have access to more training contents. So we created this, what we call learning experience. And in this learning experience, you have all the content from the domain. So if you want to know more about structural and have access to all of our, let's say, technical content, technical training content on structural simulation, you have, for example, learning experience for Similia structure. And this includes all our lessons. Same thing for Emacs, same thing for fluids, same thing for multi-body also. So these are very interesting if you already have these tools. So this is not very expensive compared to the amount of content you have. I mean, this is really not expensive. Then, very important, if you want to know more, if you want to also to review this session or access to the previous session, I talk a lot about the previous session, which was on electromagnetism. You can just go on our YouTube channel. The webinar will be posted there. So you can just take a picture of a QR code and you can access to it. And again, also, if you want to follow us, you can follow us on LinkedIn, on YouTube, on Twitter, on Facebook. So I will take the time to have a look at the Q&A. What type of product? So I have a question on 3D scanning. So the question is, what products can you recommend for 3D scanning on excavator bucket, for example, which is not that expensive? So here the topic was more on simulation. So I think we do have some product on 3D scanning. Here I don't have a name, so what I'll do is that I will send you an answer after looking for more information on this application. But I know for example, with SolidWorks, you can now import and work on STL files. And usually, when you do on 3D scanning, what it does is that it creates STL, and after you can rework on this part. So you can import the STL part and you can do some extrusion, some stuff like that directly on the extrusion, on the SolidWorks model. So this started 2 years ago, since SolidWorks 2021, and now we can really, I mean, we have more and more capabilities on these things. So this allows you to, I mean, to reconstruct your model, your model from a 3D scan. Okay, so that's it in terms of the question I have. So thank you a lot for attending this session. I hope you you learn a lot of application. Please do not hesitate if you have more question, I don't know, later, you can still contact us through the different, I mean, through emails or through Twitter, through Facebook, through YouTube. We can comment also. So do not hesitate to contact us if you have any question regarding the simulation solution, if you want to know more, if you want to have a more explanation of each domain, also on the price, because this is a topic I didn't have today because I'm not commercial, I'm a tech guy, so I don't know the numbers. But if you want to have to know more about the price of these tools, do not hesitate to contact us. We'll be happy to answer you. Okay. So thank you again, and I hope to see you for next session.